In this video, I'm going to cover two common compound interest formulas. In this first formula here, A stands for the amount in the account after a certain period of time, so it's the account balance. P stands for the principal or the original deposit. R stands for interest rate, which we will write as a decimal. T is the time period, and N is the number of compounding periods. When the problem asks us to compound annually, we'll use 1 for N, semi-annually 2 for N, quarterly is 4, 12 is monthly, and daily is 365. Now let's try a couple problems. Let's say you deposited $3,000 at 4% interest compounded monthly. How much is the account balance after 6 years? We will be solving for A. We need to identify P, R, N, and T. The $3,000 is our P because that's the original principal. R is the interest rate and 4% as a decimal is 0.04. Since the account is compounding monthly, N is going to be 12 since there are 12 months in a year. The time T is 6. Next, we'll plug these values into the formula. A equals $3,000 for P, 1 plus 0.04 for R, divided by N is 12. And at the exponent level, I recommend putting parentheses around the exponent before you put it in a calculator. And we will put 12 for N and 6 for T. Because of the order of operations, the calculator is actually going to perform 0.04 divided by 12, then add 1 to that, and then take it to the power 12 times 6, which is 72, and get that answer before multiplying by 3,000. But you can just put this all in your calculator to get the correct answer. Try putting this into a calculator and see what you come up with. The correct balance in the account should be $3,812.23 when we round it to the nearest hundredths. Let's try another one. Now let's say you deposited $10,000 at 5.5% interest compounded quarterly. How much is in the account after 12 years? In this problem, P will be the principal. Converting the interest rate to a decimal, R is 0.055. And compounded quarterly means that N is 4 times a year. The time period, T, is 12. Next, I'll plug these values into the equation. A equals $10,000 times 1 plus 0.055 divided by 4, all to the power 4 times 12. Put this in your calculator and see what you come up with. So the final answer should be 19,261.12. Next, let's take a look at the second compound interest formula. We only use this second compound interest formula when the problem says that the interest is being continuously compounded. In this formula, A, P, R, and T represent the same things as in the last formula. However, this formula has an E in it. E stands for the e to the x button on a calculator. So let's try an example. Let's say we deposited $1,500 in an account at 3% interest, compounded continuously, and we left it in the account for 2 years. What is the account balance after 2 years? Feel free to pause this video and try this one on your own. I'm going to substitute the $1,500 for P, 0.03 for R, and T will be 2 years. So the equation should look like A equals $1,500 times the e to the x button, and in the exponent, the R is 0.03 times T, which is 2. If you haven't done so already, try putting that in your calculator and see if you come up with the same thing as I do. Rounded to the nearest hundredths, I'm coming up with $1,592.75. I hope this video was helpful in understanding the two main compound interest formulas. Please like and subscribe for more math tips.